As part of a Pew Internet and American Life project, researchers surveyed a random sample of 800 teens and a separate random sample of 400 young adults. For the teens, 79% said that they own an iPod or MP3 player. For the young adults, this figure was 67%. Is there a significant difference between the population proportions? State appropriate hypotheses for a significance test to answer this question. All right, so I'm going to answer 15 and then we're going to move on to 17. So we just want to know if the the population proportions for teens is different than the population proportion for young adults, right? So the way we can write that is the null hypothesis is that there is no difference, right? That the proportion of teens minus the proportion of young adults is 0 versus the alternative hypothesis, which is that their difference does not equal 0, right? So that means that there is a difference in their population proportions. So of course the parameters are P1, the actual proportion of teens who own an iPod or MP3 player, and P2 would be the actual proportion of young adults who own an iPod or MP3 player. So this would be my hypothesis test for a test that I would conduct, which we are going to conduct in 17, right? So referring to exercise 15, we want to carry out a significance test at the alpha equals 0.05 level. All right, so for 10.17, we want to perform a test at the alpha equals 0.05 significance level of the hypothesis stated in 10.15. So our plan is we should do a two-sample z-test for p1 minus p2 if the conditions are met. So the random case, both samples were randomly selected, right? Random sample of 800, right? So they were both randomly selected. Now let's go ahead and do the normal for both. So that's going to be n1 times p1 hat is equal to 800 times, and it was 79%, and that would be 632, which is bigger than or equal to 10, so that checks. So now the second one, n1 times 1 minus p1 hat, which is 800 times 0.21, which is equal to 168, which is of course bigger than or equal to 10. All right, so the next one, n2 times p2 hat, which is equal to, so there were 400 of the young adults surveyed, and p2 hat was 67%. So this is equal to 268, which is of course bigger than or equal to 10. Right? Let me fix that a little bit. Bigger than or equal to 10. And then n2 1 minus p2 hat is equal to 400 times 0.33, which is equal to 132, which is bigger than or equal to 10. So the normal condition is met. Now let's go ahead and check the independent condition. So capital N1 is equal to American teens, right? So that's the total population, American teens. Okay, and N2 is equal to American young adults. Okay, so remember we have to have N1 is less than or equal to a tenth of capital N1, and N2 must be less than or equal to a tenth of capital N2. Well, I think this is safe to say 800 teenagers, right, is less than a tenth of all teenagers, right? And 400 is less than a tenth of all 400 young adults is less than a tenth of all young adults, right? So we have the independent condition, the normal condition, and the random condition met. So all the conditions to do this test are met. So let's go ahead and do the do. So for a hypothesis test, a two-sample hypothesis test, we need to come up with what's known as a pooled proportion. So a pooled proportion is calculated as n1 times p1 hat plus n2 times p2 hat over n1 plus n2. And we did this calculation earlier, n1 times p1, right? n1 times p1 hat is 632, right? So 632 plus, and then n2 times p2 hat. So n2 times p2 hat is 268. 268 all over 800 plus 400. And then this turns to 0.75. So that is our pooled proportion. Now we're going to do our test statistic, which requires that pooled proportion. So this is equal to, so remember our P1 hat was 0.79. Let me move this a little bit. Okay, so 0.79 minus 0.67. Oh, yeah, and then minus, and then our null proportion is that 0, right? So 0 over the square root. So our pooled proportion was 0.75 times 0.25, right? Over 800 plus 0.75 times 0.25 over 400. And then this gives us our test statistic of 4.53. All right. So since this is a two-sided test, as you can see, I have that here. Let me move it up. Since this is a two-sided test, first off, our z is 4.53, which if we go to our table, you see here's our table, 4.53 is not even on there, so it's basically, it's not even on there, so the probability of z being bigger than that is basically 0, okay? So let's go ahead and go back. So the p-value, so since this is a two-sided test, we need to do 2 times the probability that z is bigger than 4.53, which this is practically 0, so 2 times practically 0 is still 0. So instead of those, I'll do the squiggly ones, right? So this is practically 0. So our conclusion is, since the p-value, so the p-value is practically 0, right, is less than alpha, which is 0.05, we reject h naught, that these are, that their difference is equal to 0. And we conclude that the actual portions of teens, of young adults who own iPods and MP3 players, are different, right? We have to reject the null hypothesis, right? That their proportions were the same, that their difference would be 0. All right, so that's how you would do a test involving proportions, involving two samples with the proportions, right? And trying to see if the proportions are the same or not, right? Now we're going to do construct and interpret a 95% confidence interval for the difference between the population proportions. And we're going to explain how the confidence interval is consistent with the result of the test in part A. Okay? So let's go to part B. So our state is we want to estimate the difference P1 minus P2 at the 95% confidence level. And our plan is we should use a two-sample z interval for P1 minus P2 if the conditions are met. Of course, we check the conditions in part A, so we know that they're met, right? So let's go ahead and do our do. So N1 was equal to 800, right? And P1 hat was 0.79. N2 is 400, and P2 hat was 0.67. So let's go ahead and construct our confidence interval. So our 95% confidence interval, remember that's going to be 1 minus 0.95 over 2, which gives us that 0.025. So let's go ahead and find that in our table. Okay, 0.025, which is what I have here highlighted already. So that associates with 1.96, okay? So let me go back. So that means our z that we're going to plug in here is 1.96, right? So this would be negative 1.96 and positive 1.96. So this is equal to, so our p hat, our p1 hat was that 0.79 minus 0.67 plus or minus 1.96 times the square root of 0.79 times 0.21 over 800 plus 0.67 times 0.33 all over 400. And then this gives us our 0.12 plus or minus 0.054. And then this gives us our interval 0.066 and 0.174. And notice right off the bat, 0 is not in our interval, right? So this is telling us that the difference of the proportions, right, should be, of the population proportion, should be between about 6.6% and 17.4%, right? So 0 is not even in there. So it is consistent with the test that we did previously, right? Okay, so we are 95% confident that the interval, so the interval that we calculated, captures the true difference in proportions of teens and young adults who own iPods or MP3 players. This suggests that between 6.6% and 17.4% more teens than young adults own iPods or MP3 players. This is consistent with the conclusion in part A, since 0 is not in the interval that we got.